Assalamualaikum and hi, my name is Muhammad Saleh and I'm currently a final student of University Malaysia Pahang. So today I would like to present my study on determination of drawdown due to groundwater pumping using Darcy's law. So my supervisor is Madam Shairul Rohaziawati binti Samad from Faculty of Civil Engineering and Earth Resource. So this is the content that I'm going to present. So I will start with presentation with introduction. So the groundwater is an important part of the hydrological cycle and must be able to play a greater role in adding water utilities in the country. Groundwater is water located beneath the ground surface and underground water movement in soil and rocks, usually crust. It can produce a quantity of water that can be used. The depth at which soil pore spaces or fracture and voids in rock become completely saturated with water is called the water table. Groundwater is recharged and will flow to the surface naturally. The function of groundwater is also often used in the extraction well operating activities, agriculture, industry, and manufacturing. Groundwater pumped more often in areas where the pumping total more than the natural flows. Typically, such hydrology test pumping will be done to achieve the target aquifer. Next is motivation. The motivation of this study is to analyze and prove the experimental and theoretical of drawdown in different types of soil by using Darcy's law. Typically, monitoring of groundwater level due to the water extraction or pumping in an aquifer is an importance as a fundamental for groundwater resources management. In order to study about this effect in groundwater aquifer, the hydrology apparatus was be used to analyze the drawdown of groundwater pumping with different sizes of sand, which is fine sand and coarse sand. Objective. The objective of this study is to simulate the drawdown using two types of soil and to compare the theoretical and experimental values using Darcy's law. So this is the scope of study. This research study was about the groundwater drawdown by using Darcy's law. The experimental value were collected using hydrology apparatus in hydraulic and hydrology laboratory in University Malaysia Pahang. The theoretical values were using the formula of Darcy's law. During the experiment, this study will use two types of soil, which is coarse sand and fine sand, where it has a different size of particles. Significance of study. Darcy's law states that the amount of water flowing through porous media depends on the energy driving the water flow and the hydraulic conductivity of the porous media. A hydraulic gradient causes water to move, and is the change in the total height divided the distance over which the change occurs. Smaller grains such as the fine sand that is used for this study means have a smaller pores or area available for flow, and it has more frictional resistance. Therefore, the hydraulic conductivity will be lower. As for the coarse sand has a bigger size and holds therefore less frictional resistance and lower hydraulic conductivity. The flow of water through the soil is dependent on the permeability of the soil and the hydraulic head causing the flow. The drawdown for coarse sand is more steep than the fine and sand due to water move faster and fill porous media as well. So this is a literature review that I read from sources of journal. So this is the methodology. The first methodology that has been done is laboratory in UMP at Hydraulic and Hydrology Laboratory by using hydrology apparatus, which is HM165 basic hydrology system and TQH313 hydrology apparatus, and sand that being used is coarse sand and fine sand with diameter of 0.75 mm and 1 mm. And then after experiment, I continue with data collection and then data analysis and discussion. Lastly is conclusion and recommendation. Result and discussion. In this study, I used two types of sand such as coarse and fine sand. Four conditions were stimulated. First condition is two wells open. Second condition is well number 1 open. Third condition is well number 2 open, and fourth condition is pond. So as we can see in this picture is the location of the wells and the picture of piezometer tube. The wells are located between piezometer tube 6 and 7 for well number 1 and between piezometer tube 14 and 15 for well number 2. So this is the comparison of theoretical and experimental value of drawdown between coarse sand and fine sand. For the first case, which is groundwater level for 2 well open, as we can see here, for the coarse sand on groundwater level for 2 well open graph shows that experimental value was different with theoretical values due to during the experiment the rate was controlled when pumping, and the drawdown at the piezometer tube was measured, while for the theoretical value was using Darcy's law equation that assuming the near perfect condition from the experimental values. And for the fine sand, both experiment and theoretical values for fine sand was almost the same, proof that it has a good agreement between both values. It shows that the result is accepted for both values. From this graph, the red line stands for the theoretical values and the blue line stands for experimental values. The initial groundwater level for coarse sand is 100 mm and the highest difference was at piezometer tube 6 with 27.93% difference. Next, for the fine sand, the initial water level is 177 mm and the highest difference was at piezometer tube 15 with 7.77% difference. So next is the graph represent the comparison of for cases number 2, which is well number 1 open. The initial water level for coarse sand is 141 mm, while for fine sand is 185 mm. The highest difference for coarse sand was at piezometer tube 4 with 6.2% difference, and for the fine sand the highest difference was at piezometer tube 3 with 2.02% difference. Next is the graph represent the comparison for case number 3, which is well number 2 open. The initial water level for coarse sand for the experimental is 109 mm and the theoretical is 135 mm, while for fine sand is 187 mm. The highest difference for coarse sand was at piezometer tube 50 with 70.82% difference, and for the fine sand, the highest difference was at piezometer tube 15 with 1.98 difference. As you can see here, the drawdown occur for coarse sand is more steep than the fine sand due to water move faster and fill porous media as well. This is because coarse sand has bigger pores which are available for flow and therefore less frictional resistance, so the water will move faster. The last graph here was represent the case number 4, which is pond condition. As we can see here, the drawdown occur for fine sand is more shallow than the coarse sand due to water move slowly and fill porous media as well. This is because the fine sand has smaller pores which are available for flow and therefore more frictional resistant. So the water will move slowly and drawdown is shallow. So the highest difference for coarse sand was at piezometer tube number 6 and 7 with 72.9% difference. And for the fine sand, the highest difference was at piezometer tube 14 and 15 with 36.67% difference. So this is the percentage of difference of coarse and fine sand. So after calculating the percentage of difference at coarse sand for pond case shows 72.90%, which is far from the theory, while for the case of well number 1 open is close to the theory by 6.20%. For fine sand, the percentage of difference that far from the theory is for pond case with percentage of 36.67%, while for the case well number 2 open is close to the theory by 1.98%. So as the conclusion, what I conclude is that based on the experiment on opening the 2 wells for both soil shows that for the coarse sand, the initial water level and the level for the water to undergo drawdown is smaller in values. It shows that the water moves faster at the bigger size of the sand as well. While for the fine sand, the initial water level and the water level that undergoes drawdown is more bigger in values. After calculated by using Darcy's equation, the result for the experimental value shows different from theoretical values. Experimental value is higher than the theoretical values due to the rate was controlled when pumping and the drawdown at piezometer tube was measured, while for the theoretical values was using Darcy'S law equation, assuming the near perfect condition from the experimental values. For fine sand, the value has almost the same is the proof that the result can be accepted for both experimental and theoretical values. It also can be proved that the equation is valid to apply in the hydrology field, especially in groundwater pumping study. Percentage of difference of cost sand for point case shows 72.9%, which is far from the theory, while for the case of well number 1 open is close to the theory 6.20%, while for the fine sand, the percentage of difference that far from the theory is for point case with the percentage of 36.67%, while for the case well number 2 open is close to the theory by 1.98%. So this is the recommendation. The drawdown data collection should be improved in order to get an accurate reading. Perhaps that we should also improve the techniques in data analysis. For example, during reading at piezometer tube, make sure the water level for all cases are the same. The apparatus should be serviced before doing the experiment. Next is the rainfall for both apparatus should be the same, as some of the sprinklers were not properly functioning well. And for the future study, other method that can be used to compare with Darcy's laws is team method. The team method is very simple in principle. It consists of pumping a well that penetrates water-bearing material, the permeability of which is to be determined, and observing the decline of the water table or piezometric surface around the pump well. So this is the reference that I use for my study, and I guess that is all from me. Thank you.